Alrighty, recording started. Okay, and I'm going to share my screen now. All right, can you guys let me know when you can see my screen?
Yes, we do.
All right, perfect. So, all right, so let's get this started. For today's meeting, what we're going to discuss is the Kotlin multi-platform, um, and how do we actually, build apps that work in many platforms. And so I'm going to do something a little bit different this time. I'm going to start with the end to discuss what to expect. Um, so right here, we expect from this benefits. All right, never mind. Let's just start from the top. Okay. All right. So what do we need to start this, building apps for multi-platform? So there is some prerequisites that we need to understand, for this meeting to go well. So I would like to ask the question, I'm gonna guess that everybody in this meeting has some understanding of programming, right? Because technically, if you've been following the last couple presentations, you probably have a little bit of, programming background or some basic understanding of what it is. Am I reading the room right? Alrighty, so I'll take that as a yes.
Yes,
And
yes.
say that again.
I say it's a yes.
Okay, perfect. Thank you. So I'll take that as a yes. And um, so with this meeting, I try to actually go a little bit uh too deep by giving more understanding of the underlying like architecture and all that to expect from multi-platform programming and all that. So if you feel like I'm going like that, what I'm presenting is not beneficial, it's like too light, or like it's not to your level, just let me know and then I will skip. But I just wanted to make sure that anybody in the meeting gets what they looking for. All right. So what we will be building in this at the end of this presentation is a smart clock that will work for Android and iOS. And so some prerequisite to have is you need to have like a basic understanding of Jetpack Compose. And there is some links that can give you like a good, you know, um, head start on what Jetpack Compose is and everything. So you also need some level of Kotlin, um, and then you need to have an Android Studio installed on your computer. And this part right here is if you have the Ladybug, the Android Studio Ladybug, the latest version, it comes with a K2 mode, which is in beta for now. And because of that, it's not yet supported by the KMP, which stands for Kotlin multi-platform. So you need to disable this before you can actually install the Kotlin multi-platform plugin on your Android Studio. Otherwise, you will get an error message. You also need to have Xcode, and the reason why you need these two is because this one comes with an emulator that you can just use to run your app on the IDE itself. without having to have a an external hardware device for it. And then the Xcode does the same thing for iOS. Alrighty. So applications. So usually when we hear apps, right? We hear apps, and then the reason why I'm touching this part is because we hear apps everywhere. You hear web apps, you hear mobile apps, you hear like apps all together. So what does app mean exactly? So technically what it is, it's just a tool that or program that allows you to, execute certain tasks, right? And then, you can execute them on different devices, let's say phones, tablets, computers. So when was the term app first used? So, technically it became popular, around 2008, when smartphones started becoming common. Before that, the term app was there, but it wasn't really used that much. Um, and then so why are apps needed? Apps help users complete tasks easily, and then they make life more convenient, right? So they provide a way for you to communicate with the hardware or the platform, when we get to that. And then so by hiding some of the complexity behind the scene. So instead of you having to type like zeros and ones to, have the computer do something for you, the app will actually just give you like, let's say a UI, which stands for user interface, that allows you to interact with it. So how do apps work? So apps use a combination of hardware and software. They connect to your device system using APIs, and then which are tools that help them work smoothly with your phone or your computer. So this part right here, I'm sure we discussed about APIs, but I didn't find the need to actually bring this again. I'm sure most of us by now know what an API is, but if not, technically what an API is, it's just like a communication, what do you call it, a communication mean or way for um a, an object A to to be able to send instructions or whatever to an object B, right? So and then it can be from a server, it can be on the device itself, but it's just the easy way to look at it is person A communicating with person B can actually use an API for it. Uh, so an example of an app would be like a weather app. You know, it gives you the weather data, and then as you can see, you can collect the data from the server and then show it on the screen. So the data collection part, as a user, you definitely don't care about how they get the data. You just want to see what is the weather like out there. And then the best way is to make it in a human readable format. And then so that's and then that also stands for user friendly, right? So platforms. What is a platform in an app development? So a platform is an environment where apps run, like Android, iOS, and web, right? So you have the web browser, which you can use like JavaScript for, as the language. You have iOS, where you can use like stuff like Swift and C Sharp. You have Android, where you can use like Java, Kotlin, and C++ or C, right? iOS as well, you can use C. So when was the term, platform first used in the development world? The term became widely used in the 1980s, um, with the rise of operating system like Windows and Mac OS, right? And then, if you remember up here, we said that for apps, it's like around the 2008, and here it's around the 1980s, 19, actually, yeah, right here, 1980s. So when Windows and Mac started competing around that area. So why our platform needed? Platform make sure that the app can run properly by providing the tools and rules needed for development. So that takes us back to the API and also, some of the protocols, right? So for an app to actually exist or work, it's literally just instructions that you're sending to the computer. So what these people did, they actually created platforms that allow the apps to talk to the computer without having to code like deeper, like without having to use the zeros and ones, right? And then so also by following certain protocols and all that. And then so like a MacBook, a Mac OS, you know, probably if you look at the top bar and all that, reacts differently than a Windows, bottom bar, the taskbar. So and then so that's platform for you. So how do platforms work? So they give developers tools, libraries, and framework to create apps that work well on their systems. So technically, that's what they do. And then example of mobile platforms, we have like iOS, which is famous for its security and smooth integration with, Apple devices. And then you have Android, which is known for more flexibility and freedom, right? Um, so now we talked about apps, we talked about platforms. So as you can see, in order for an app to work, properly, it needs to exist in the platform, right? You can code it platformless, which is where we're coming. But, to make it easy, these people created frameworks and platforms that come with frameworks and libraries that allows developers to build apps easy, right? So now, you know, everything is going well because if let's say I'm building an app for Android, cool, they made my life easy. But now, fast forward, I am part of a team and then the team needs to build, the same app for iOS. And then, because the platforms are different, now the same code will not run on both, right? So now we have to either find somebody who also know how to program in Swift and, C Sharp or whatever, um, on top of an Android developer. And then that comes with cost. And it also comes with, comes with cost of time and money and, maintaining the apps too. So because of that, some people have attempted to actually just, merge both, right? Make sure that, you can build an app that works on one platform and also works on another platform. So that's where the term multi-platform makes sense. So what is a multi-platform app? A multi-platform app is designed to work on more than one operating system, using a single code base. Uh, Single code base keyword, we will get back to that later. And, when was the term multi-platform app used? The idea became common in the 90s with tools for building apps that work on different, systems. So same 1980s, the term platform came up, and then 10 years later, people started thinking about, okay, how do we, build apps for that works on both platforms, right? So why are multi-platform apps needed? They save time and money while making apps available to more people, right? We just talked about that. Also, how do multi-platform apps work? So you have frameworks like Flutter and Kotlin multi-platform that lets developers write one set of code, which is then adjusted to work on different platforms. So remember, single code base adjusted. So what does that mean? If we're talking about single code base and we're talking about adjusted, so does it mean that we have a one big repo and then in there we adjust stuff? Or does it mean that we have like fracture of like codes, but we just keep it in one area? So we will get to that. So pros of multi-platform apps, they save time, they cost less than separated apps, and then they allows sharing of logic. So sharing of logic is, let's say I'm building a tool that, you know, does something on the back, right? It does some mathematical, calculations. And then it's literally like a formula that, is complex or whatever, you know, like encryption, right? So I don't need to build that logic twice on different platforms if I can just have, one app, that works on multiple platforms, provide the UI, and then everything is done on the back, that way, the code is shared among like across the platforms. So the cons of multi-platform apps, they may run slower than native apps. That's, one, negative side of it. And then they provide limited access to some platform specific features, right? So they might provide limited access to, like, let's say the Bluetooth, or, let's say you're building an app that, has advertisement, and then iOS decide that, we're going to suspend, the ads altogether. And then we're going to force users to, to have to do it differently. So then, you're probably not going to have access to that feature anymore, while it's there on the Angular Android world. That could create some frustrations, based on the users. But again, we passed that already because people probably get the information ahead before your app even start to not have those features anymore. So when to use multi-platform apps, please stop me, if I'm going too fast. I'm just trying to go through the nitty-gritty, and then, let you guys know if you have questions. So when to use multi-platform apps, what are they good for? So apps with simple design and heavy reliance on backend services, just like we mentioned earlier. And then not ideal. When is it not ideal? When you're building game apps, because they rely on a lot of like front end, uh, stuff like UI, stuff. And then when you also need advanced hardware access, right? So just like we discussed, the Bluetooth access and all that, or let's say um, iOS, the newest iPhones, they come with like 3D scanning and all that. And in Android, I think, up until a certain level of Android, you don't have 3D scanning. So you might not get it in the Android world, but, iOS will offer it. So that's something to consider. So examples of frameworks, we have Kotlin, which is, multi-platform framework. You know, um, it focuses on reusing code for Android and iOS and more. More stands for desktop, web, as well, and even back end, right? Even if you want to build like, APIs in the back, or REST APIs, you can use Kotlin multi-platform for it. Um, so this whole thing is going to be like a series of, presentations. So we're going to focus now on the Android and the iOS, and then later on we'll progressively, add more to it. So Flutter creates beautiful UIs with one code base. The only difference here is that, I believe I have it down here. If I don't, I'll just talk about it. So the only difference between the Kotlin multi-platform and the Flutter is that Kotlin actually uses, like, it converts the code into native, while Flutter requires a middleman. Flutter has like a, let's say, a virtual machine where the codes get sent there, and then the virtual machine will translate and then send it to the device. And then, as you can see, just having one extra layer can make things slower, right? And then, now it's like you have to worry about, is this layer also, up to date and all that. But with Kotlin, they, technically just translate the code into either whatever Android can understand, which is, Java mostly, and then, yeah. And then iOS, it's native, bits. And if it's for web, it's going to be in JavaScript and all that, so on. So Jetpack compose multi-platform. All right, wait a minute. So why are we talking about Jetpack Compose multi-platform? Is it really a multi-platform? This is a UI tool, right? It builds UIs. So why are we talking about multi-platform here? So Jetpack, the advantage with Jetpack is that, they also aim to, technically conquer the UI world when it comes to multi-platform, where you write one single code and then, they will make sure that it matches the UI on, both devices. So, that's also one advantage of Jetpack. I'm going to talk about it now, but in this presentation, we're not going to add Jetpack multi-platform. We're just going to use it in Android. And then later on a different presentation, I will, discuss how we can use one shared code for UI. So what is Jetpack Compose? As the name, or as you guys may know already, it builds user interfaces in a simple modern way. And it's commonly used in Android apps, but can also work on other platforms. So when was, Compose first introduced? Google announced Jetpack Compose in 2019. That's, from 1990s and all that to 2019. That's a bunch of years, right? But again, the need came up, and then they figured that, or probably a team of people just decided that, what, let's work on something cool. And then they worked on it, and then, they got the funds for it, and then it became a project. Uh, so why was Compose created? It makes creating UI easier and faster by using a new approach called the creative programming. That's what, they gives them the advantage. Um, and then I'm not gonna go into the details of this because it's not, and we're not gonna use Jetpack Compose yet. So when we do the presentation for it, we'll go into details. So the benefits of using Compose, it provides simple syntax. If you know what Jetpack Compose is, you would know that it definitely provides simple, easily understandable, syntax. And then this is an example, right? So you have a composable, and then you have a greeting, and then you have a text in it. Like, just by reading this, you can understand what's going on here. Um, and then, it also provides state management, and that's a huge thing, right? Because when you're building UI, state management is a huge thing because you might be updating the data somewhere where the UI is presenting old data, so everywhere, like, state management is required. Let it be data, let it be like the UI itself. Let's say you want to update the page, or like the fragments or whatever. you know State management is a good thing, a huge thing. So, and then reusable components. So, as you can see, reading, and then it takes a name, and then a text, and then it does this. So once you create this, you can literally call it everywhere. And then, so, that makes it so much easier to use across, uh, activities, which stands for pages, and also, the same code base. So the challenges of using Compose, so, the learning curve, right? Just like any programming language, there is always a learning curve, but, Jetpack isn't that complex. You can get it if you put your mind to it and you don't hate it. Yeah. So ecosystem growth, some features are still developing, and, for the multi-platform, but they have a pretty good, library of UI tools that will work good for, the regular apps. But if you're building, like, let's say, games, or like apps that are really, really like cool looking, or like create complex, you might actually not find it beneficial. That's it. So now, We talked about multi-platform, we defined what it is, and then we also talked about the Jetpack multi-platform. Now let's talk about Kotlin, which is why we're here, right? So the Kotlin multi-platform. So what is Kotlin multi-platform? It also stands for KMP, you know. So KMP allows developers to write share code once and then use it in many platforms. So here I'm gonna open this documentation right here real quick, and then so this is the reason why I opened this, right? And then so simplify the development of cross-platform projects and reduce the time spent writing and maintaining the same code for different platforms. You know, so and then we also have like some fundamentals and all that that you can go through. You know, you have the shared logic, you know, but you keep the UI native. So there's two types. Actually, let me not get ahead of myself. We're gonna get back to this. So when was KMP first introduced? You know, JetBeans introduced KMP back in 2017. You know, that's when it was first introduced. And then JetBrains is actually the, you know, the team that actually manages, supports, and updates the KMP. So why was KMP created? It helps developers avoid writing the same code for different platforms while keeping good performance. You know, so it gives you the tools to write, like to be able to just write one single code base and then decide whether or not you want it to just work on one platform or work on like two different or one or many platforms. Let's just put it that way. uh and then while not affecting the performance, right? Because there is ways to build for multiple tools, but again, is it going to be performant? That's also the question. So the benefits of KMP: code can be reused, supports platform specific features. So if you decide that you want a specific kind of feature on one platform, but you don't want it on the other, it supports that. You don't have to worry about, customizing, excuse me, customizing, whatever feature they provide to you. You can just decide that, okay, you know what, this is only going to be on Android. I don't want this on, you know, iOS. Um, or I don't want this on the web browser. So it delivers native performance, close to natives, So I won't say native performance, but close to it, because there is still the compilation and all that stuff going on, right? But it's pretty fast. So challenges of KMP, can be harder to learn, because we will get to that. Um, it comes with a lot of, you know, a lot of orders to manage, and then has some hoops and loops that you have to go through, and because of that alone, it actually makes it hard, right? So let's just put it that way. If building an app for one platform is hard, now imagine building an app for two different platforms that have nothing in common. So that means you have to go back and forth, and then your code base might actually look confusing a bit, right? If you don't think of all that ahead. Uh, and then it has a smaller community compared to some other tools, but it's pretty strong. It just came out 2017, is not far out. So but the community is still growing. So now, how does KMP work? KMP uses tools to create versions of your code for different platforms like Android, iOS, or the web. So technically, that's what it does. So it takes your code and then it creates another version of it. It creates a version of it that will be compatible with Android, and then a version that will be compatible with iOS. And then we mentioned that those briefly, like Java, native, bytes, and JavaScript and so on. So platforms supported, so far the only platforms that are supported are Android, iOS, web, desktop, and server. I did not put server here because I honestly don't know why I would use KMP for building a server app. I honestly couldn't make a reason for it, but they do have compatibility for it. They do support it. Um, so comparing KMP with Flutter, right? So the language, KMP uses Kotlin, Flutter uses Dot, and then performance, native, and then near native, right? And then the ecosystem is growing for KMP, and Flutter has been around for a minute, so the community is pretty much big, and then the ecosystem is established. UI frameworks, in Kotlin you can use Jetpack Compose for multi-platform, and then Flutter provide that, already. The downside to this is that if you're building something that Flutter does not, you're building a UI for a platform that Flutter does not support, then you have to wait for Flutter to do it, right? Versus if Jetpack and Kotlin are separated, right? So you can decide that, okay, you know what? I'm not going to use Jetpack Compose because they don't support, the chicken that can swim. So what I'm going to do, I'm just going to use, another, UI framework that does it. Flutter doesn't allow you to do that. You just have to pray for it that they add that. So now example of shared logic, right? So any questions there? Let me stop here first. Any questions? All right, I take that as a no. So example of shared logic. So, the get platform name is like a code that can be shared across, you know, um, platforms, because technically this code right here is a KMP code that just gets the platform name. So if the platform is Android, it would just say Android. If it's iOS, it would just say iOS, you know. And then here, you can, declare it and then just return what you want to return. And then you can use that on Android devices and also on iOS devices, because there is no reason for you to actually write this code twice, because it wouldn't make sense at all. It's just getting the platform name. So
Uh, a
now,
quick question on that.
mhm,
The part that says actual, if you scroll up a little bit,
uh-huh.
this one will be written for each platform, right? The actual,
the which part?
where it says expect function get platform name, and then actual function get platform name.
Yeah. So this one would be platform based, and then this is the one that is, look at this one as what do you call that, an abstract class, like the parent class that will give you access to getting this. But we will get to it.
Oh, okay,
Once I show the code, you will see what it looks like.
sure.
So, all right. So, any other questions before we start, talking about code? All righty. So now let's go back to the documentation again. So I was going to touch on these, but again, I said we'll get to it. So now we are there. So there are two ways to build multi-platform, apps, right? You can build it with shared logic and shared UI, or you can build it with shared logic and separate UI, or you can build it with both shared logic and shared UI. Um, do you guys understand what those two mean?
No.
No? Okay. So the UI is everything that you can interact with. And then the logic is the logic that you're building. Let's say you're doing some mathematical, calculation, right? That would be a logic. You can share that on the Android world and also on the iOS world, you know. But when it comes to the UI, you can choose to say, okay, you know what? I want a different UI on the iOS than on the Android. A good example would be the calculator on your phone. If you pull your calculator on the Android devices, somebody correct me if I'm wrong. it's definitely not going to look the same as the calculator on the iOS device, right? But we all know that square root of 4 is 2. So that would be a logic. So the logic can be shared, but the UI, which is the calculator, how it looks like, can look different. Or you can actually make the UI look exactly the same, where you pull your Android phone, whether you pull your Android phone or your iOS, your app, iOS, yeah, your iPhone, you're gonna get the same look and feel of what the calculator looks like. Does that make sense?
Yeah, so this is just gonna be like when you have a desktop app for Mac and a desktop app for Windows. On
Mm-hmm.
Mac, to close the window, it's on the top left corner.
Yep.
On Windows, it's on the top right corner, for
Yep.
example.
Yep. So that's a good example, right? And then, or you can even build it and then just remove the close area and then just make it look like a plain thing, and then you add a button in it to close it. That way, you just decided that you want to make it shared on both, right? That
So
that.
yeah,
Mhm.
so the shed will not look like a regular application of that platform, right?
The shared UI,
Yes.
yeah, it will not. It could, right? Because it depends on what you use, but it will not. Mostly, it will not look like it. And then we will get to that. I have an example for it.
Okay.
Yeah. Alrighty. So now, uh, so we talked about this. So the shared logic and native and shared logic with shared UI. So setting up the environment. So the first thing we need to do, we need to install Android Studio or IntelliJ IDE. I'm definitely going with Android Studio because I like to test on the IDE directly. And then we need to add Kotlin multi-platform, right? So this part right here, it took me, it didn't take me that long to figure it out, but it took a lot of, frustration to finally look for a solution for it because I was literally going to quit using Android Studio and then I was going to use an IDE that they recommend called Fleet. It's a new IDE and it's pretty, from what they're saying, it's pretty good. The only thing is that it's still new and it's still under development and it's not going to be free later on. Right now it's free, but once once they pass that level, then they're going to start charging people for it. And then that's
Yeah, I
what is
think
it?
it's the new competitor for VS Code.
Yeah, for VS Code. Yep, but it's not free, so I don't know if it will come.
You have to have the
Hopefully it's
subscription.
free. Yeah, and then as you can see, JetBeans Fleet is currently public preview. At this stage, it is free to use. Yeah, so they made it clear. So um, I did download it. I can show you guys quickly what it looks like. Let me just. But again, I can't talk to it at all. I can't talk about it. So it looks like this, and then as you can see, SSH, Docker, and I don't know what code Canva is. Something that I need to research. Ben, do you know what it is?
Code Canvas. It's probably related to the AI stuff, I think.
Got you, maybe.
Sure.
But like just those two alone are actually, a sellout, right? If you can just integrate your Docker easily and all that, it might help. So,
I
and
think
then,
the
mhm,
main thing about Fleet is that when you compare it to VS Code, because that's what it competes with, in VS Code, you have to pretty much install a whole bunch of plugins, right?
yep,
In Fleet, it's automatic.
yep,
So, so for most used languages, you don't have to do anything. It just there's a mode when you open a project, you just enable it, and then
mhm,
it figures out what type of project and all, and then it has
yep,
the right configuration to give you autocomplete, LSPs, and so on and so on.
exactly, yep. And then they also talk about collaboration. They actually talking about it as if that's something that they exceed on, something to look into, right? But
Yeah.
yeah. So now back to what we were discussing. So now need to install Android Studio, and then we need to use, the JetBrains Kotlin multi-platform wizard. So let's just go slowly, right? So this is Android Studio right here. And then I'm gonna close this, and then I'm gonna close another one. And here is, when you install Android Studio and you open it, this is your welcome page. This is where you would find your plugins, and then the Kotlin multi-platform. Let's see if KMP will work. Nope. So Kotlin. All right. So this is the plugin that they're talking about. And then you just need to, enable it. So I'm going to do something real quick to show you guys, some of the concerns. So this is where I am, and then I'm gonna go to languages, Kotlin, and then this is the K2 mode that I was talking about. You need to disable this. I'm gonna enable it, and then you will see what will happen. So I did not apply. Restart later. Yep. All right. So now let's restart it. And then it's
So what is K2? Is it the new compiler for Kotlin or what?
yeah, it's that. It's like, to be honest, I don't even want to know what it is, what it does exactly, because it gives me a hard time already. But yeah, it is like a compiler. So now you see what error I'm getting. So plugin Kotlin multi-platform wasn't loaded because it is not compatible with the Kotlin plugin, in K2 mode. So now if I go here, and then I'm gonna type Kotlin multi-platform. And then so now I get this big red thing, right? So now I'm scrolling down and I'm like, man, what's going on here? So I go to the reviews. This is a tool that was actually praised, right? People were actually using it pretty good. They were giving it good reviews. But just because of the K2 mode and because they did not actually communicate this well, look at the reviews. Now they get 1 stars. I'm sure they will get 0 if some people could put 0, And then they did not respond to any of them. And then I'm like, you know what? I don't think I want to use Kotlin multi-platform anymore, because if they can't just respond to something simple like this, what the heck? Like, So I just decided to just do my own due diligence and then just go research it, right? And then Kotlin plugin disable and go to K2. I believe this is it right here. All right, and then you come here, and then now they're finally talking about it. Hi, currently the IDE plugin, which depends on Kotlin IntelliJ plugin and are not explicitly, whitelisted, are disabled in K2 mode, since they might be incompatible. So why wouldn't you share this like directly in the plugin? Why do I have to come here to figure out that that's the problem? Which is not even their issue, right? But that's what they get. So now going back, let's go, and then we're gonna change it. So I'm just doing this repeatedly so you guys know where to go. So it's in settings, and then under language and framework, you will select Kotlin, and then So just enable this, and then Ben, your question. So K2 mode brings stability and code analysis improvement. Some functionality is still in a work in progress, and so on.
Yeah, but also I'll just one remark for the defense. Next to K2 mode, it says beta.
Yeah,
So
so K2 mode is beta, but again, that means the problem is not Kotlin multi-platform issue, right? But because they did not disclose that, they did not, openly, discuss that, right? Now people are blaming them for it, and then they're giving them bad reviews.
right, but was it enabled by default or did you enable it?
So when you download the Ladybug, the latest Android Studio, it comes enabled by default. So it's
Oh,
really not their fault.
okay.
Yeah. So restart, and then so now you are we are here, right? So you can directly. So now we need to enable the plugin. I believe it's enabled already. Yeah, it's enabled. So we can come to projects, new project, and then we can just create it. Hold on. Yep. New project. I guess they even removed it. Oh, here we go. So you can create Kotlin apps here, or Kotlin multi-platform libraries here, but I wouldn't recommend it. It's not recommended by the JetBrains team. They built a web UI, a web wizard that allows you to create the project. That way, it comes with all the nitty gritty, and then you don't have to install extra stuff. So now back to the GitHub. So if we go to here, right? So use the JetBrains Kotlin multi-platform wizard, and then so if I click on it, that's what it looks like. So you provide your project name, so project 0, and then you can provide, your package name and all, and then you can choose whether or not you want it to be, enabled for Android, uh, iOS, desktop, web, and server.
Yeah. Are you selecting desktop as well?
No, not this time.
Okay.
Yeah. So now this is the part where the shared UI comes, right? So you can choose to say that, okay, I want the shared UI for both, or I don't want it. So now
Oh,
Mhm.
just one thing. I think I know why the server is there. This is, I think, to build an API, that
Yeah.
will back up those applications. So
Oh,
the Android, iOS, and web, these three will be the front ends. Okay. And then, I mean, as well as the desktop, it will be the front end. And then server will be the data part, like serving an API.
okay, I see what you mean. That way you don't have to worry about which
Yeah.
library actually will give you the best, right?
Yes. And you will have some, I think, reusable like packages. Like for example, if you define some models that interact with the database and serve the object over the API,
Mhm.
uh, within the same project, you could have the iOS part, have the client version of it to deserialize it and use it in the project. So,
Yeah, makes sense. Yeah. So that could be a use case for it. And then so let me uncheck this. We will get back to these later on, web and desktop. I don't know. You guys tell me what do you think? If I should like do iOS and Android, then later on desktop and web, or just progressively add them. You can let me know at the end of the presentation. So now, all right, we selected those two, and then you can also choose to not use iOS and then just use desktop and Android, right? So it's not like you have to have both and then the rest. So, and then once you do that, and then you just download. and then it creates a zip folder, a zip file, and then you can just unzip that, and then that comes with most of the stuff that you need to run your project. So now we're going to go back to Android Studio, and then we're going to open that project. So let's click on open, and then download project 0, open, and then let's allow the computer to trust this. And then now we just need to let it go through its course. And then so it's just gonna, try to install and import all the stuff that is needed for the project to work well. It also comes with a README, that you can use to pretty much just, update or like understand what's going on, but this was not useful to me because, I still couldn't figure out, when it comes to the Gradle stuff, but we will get to that. So another advantage of using Android Studio, which I really like, is when you download, a project or you clone a project, and then your Gradle is like an older version, you can just use the AGP, assistant, and then just upgrade it. So don't do that too. If you were using like IntelliJ and all the other stuff, then that will be something you have to manually do. Alrighty, so now this is done. Let me see if we need to talk about other stuff before we start going through the code. All right, so now we're creating the UIs and everything, right? So before we do that, I just want to talk about how this works. So when you're building an app using Android Studio, it's best to not view it in the Android mode. It's the best way so far that I found is project files, because before what I was doing, I was going between project, which gives me, this structure. And then I was going back and forth between project and Android, because when I'm trying to build the Android app, this is easier, for me to access, right? But when I'm going to the iOS, then I have to go back here because it's just not obvious here. You don't even know where to find it. So I was going back and forth, but then played around, and then selected all these, and then I found out that project files actually gives you, everything you need in one shot. So now the one thing we need to focus on here is Compose. So Compose is for the Android apps, iOS apps, obvious, and then shared, obvious. So, and your Gradle will be inside the shared. So this is where you will import your libraries. So, and in here, you have something called source set. And then inside the source set, you have the common main dependencies. This will be dependencies that will be, for the multi-platform, that will work on both. And you can also use something like, Compose, Android main dot dependencies. And then that way you will only import the libraries that will be for the Android. And you can also do the same thing for iOS. And then you will import whatever will be just for the iOS. All right, we won't need that because for this thing, it's just a a smart clock, so we won't need much of like feature-based dependencies or like platform-based dependencies. So now Jetpack Compose to design the app. All right, so before we get there, let's continue. So in the shared, now you have three other folders. So you have the Android main, you have the common main, and you have the iOS main. So common main is shared, Android main obvious, iOS obvious, right? So we come here, Ben, your question. So you see how we're getting the platform here, and then we have an interface. And then if we go to the Android, now we have platform that Android, and then we're defining the name.
Mhm.
And then we're providing a version number and all that. Same thing with the iOS as well.
Right.
Yeah. Okay, so let me
So,
hide these
so
again.
the actual is what is it called? The actual function for get platform, it's repeated for each supported platform in the project. Like
Mhm.
iOS will have its own Android, desktop, and so on and so on.
Yep.
So this reminds me of I don't know if anyone has done C coding before or C++.
Mhm.
It's more like in the common main when you define that there's that function signature like expect function get platform.
Mhm.
This is like saying that it's an external function that will be known at link time when it's compiled.
Yep. Yep.
So the actual definition of that function comes from a library. So if it's compiled for iOS, the implementation of that function will be uh, made available during compilation, and same thing for Android or desktop.
Yep.
Um,
Alrighty. Oh, go ahead, please. Did somebody have a question? I thought I heard somebody. Okay. Alrighty. So now that we talked about shared, now let's go to iOS. And inside iOS, we have iOS. So this is for the folder and the subfolder that we need to worry about. And then in here, we have the iOS app, which is where the app starts. And then we have a content view, which is where we load the view. And then, so now let's close this and now let's close this as well. And let's go to compose, and compose, same thing, compose and then source. Looks almost like, when you're navigating through the folders for directories for the Android. So compose app and then source. And then here you have your Android manifest here. And if you're familiar with it, that's where you import um your requirement. You import, let's say if you want to use Bluetooth, then you're gonna, require that, and then the user will get permissions and all that. And then you can also define other stuff in it, like the activities and the navigation process. And also you have common main. Here you have like drawable, but we're not going to use that. This is, as you can see, it's just nonsense. I don't even want to look at it because we're going to use Jetpack. And then, so we have resources, which gives you the drawables and the values and everything, just like you would have in when you're building Android apps, right? And then if you go to Kotlin, now you will have like your project directory, and then you will have the app name, and then the main activity. So for the Android, this is where the app starts. And then this is where you're setting the content, which is the view. And then as you can see, it's referencing the app. And then that's the view. And then this is Jetpack for you. Then we create a composable. It's an app. We use the theme is material design. And then, it's a column, then a button, then an animated visibility, then a column, image, text. And then this is the state management. So You have something that says show content, and then this is something that updates. And then based on the state or the value, we're gonna do certain stuff. So now we went through the project directories and everything. And so I'm gonna go back to the Gradle, and then I will show you guys how to import.
Yeah, so maybe can you mention the importance of that? What is it called?
Mm.
I thought there was a top level. Yeah, there's a build that Gradle that gets at the
Yeah.
top. No, not this one, below.
So this one right here,
Right.
this one technically it's just imports all the top level stuff, right? So as you can see, you have Kotlin multi-platform, you have the Compose compiler and all, unless you really want to import other stuff, I would say don't even touch this when you're building multi-platform. Just focus on the build Gradle under the shared.
Yeah. So can you open it again? I just wanted
Sure.
to. Yeah. So it looks like this one actually ties all of the different sub modules, right?
Mhm.
For example, in the Compose app, if the
Mhm.
Compose app needs to refer to something that's defined in shared, the way it can find it is because they are all bound by this Gradle file. So
Say that again. Sorry, I got distracted. Go ahead.
So Compose app, that folder, together with the, let's say the iOS app and the shared, they are
Mhm.
all bound by this file. So that if something in the Compose app wants to refer to an object or function defined in shared, they can find each other because they are bound by this file.
Oh yeah, yeah.
Right.
That's what it does. Yeah. But I wouldn't touch it. Unless you have a reason for it. So here, what we're doing here, we going to actually import what is needed for the app, right? And for this app, let me tell you guys what the app is supposed to do first. The app is um a clock that just ticks, and then whenever you wake up, you look at it, and then there is a button there, and then you will click on it, and then it will give you like a code of the day just to make your day, right? I remember when I was in training in the military, uh I had a friend there, a battle buddy, that had an Android phone, and this alarm was so soothing. It would just go like it starts smoothly, and then it just grows. And then once you reach a certain peak, it just tells you, hey, good morning. Today is whatever, whatever. The weather is whatever, whatever. And then I used to love it. So I'm attempting to actually reproduce that slowly, with this, project. So, but for now, it's just show you a clock, and then you click on a button and it gives you a code of the day. So for that, the only thing I can think of is for the code of the day, we need to get the we need to get that somewhere, right? Let it be from an API, or let it be that we actually have a database table that we're going to do. We need to get it somewhere. And then but for the purpose of this presentation, just to keep it, short and not make it too complex, we're going to use local data. And then we're just going to store it as a JSON, and then we're going to parse it. So in order for you to use, JSON stuff, you need to use the serialize. Um, but again, implementation, this is always hard for me to figure out the full name. So what I usually do, I'll go to tools, and this is how you can import libraries on in Android Studio. So tools, no, I'm in the wrong folder. That's probably why. What's going on? Am I tripping or Hey, all right, 1 second, please. Maybe because I need to build it first. Do I see a build? Let's run it. So now we're gonna run the app as it is for now, and then so compose, and then we're gonna select a device. So if you're familiar with Android Studio, these are where your list of devices are, your test devices. And then I think it's because the project is not done syncing. All right, let me just sync it. That's probably why I couldn't import the libraries. Here we go. Yep. So now if I go here, let's run it. And then I'm gonna switch to the one that is done, so that we don't have to, load all the stuff and then go with the wait time. And then I will still, discuss what we're doing. So yeah, this is gonna just do its thing. You know what? You don't want to run it on the tablet. You want it to just run it on a smaller device. All right. So while this is going on, let's come back here. So the steps that we're going to take, we're going to create the UI interface using Jetpack Compose, for the Android. And then, so this is just an example. This is not what we're going to use exactly in the code, but this is an example of Jetpack. You can have an alarm screen and then a column, a text, a button, and then, it's pretty straightforward. Um, then we also going to create the logic for each platform. These are just examples as well. And then we're going to add the core features. That's what we're doing right now. We're technically just adding the stuff. And then technically we started backward, right? But it's needed. You need to have the libraries before you can even code. And yep. So now let's switch to the app. It looks like it's fully loaded. Make this bigger. All right. Can you guys see? So by default, this is what the Jetpack created, the wizard. It created something that, as you can see, already runs fine. And then if I click on it, it just drops a logo, and then it tells you that you're running on Android and then your Android version. And then if you click on it, it hides it again. And then now we're going to run it for iOS. So if I go here, instead of Compose app, we're going to do iOS app, and we're going to run. And then what's going to happen, it's going to go through here, but again, it's not going to show it on Android Studio. Then you have to now have your Xcode, because it's asking to have access to Xcode. And then I'm going to allow, and then I'm going to bring Xcode over. This is full screen. So bringing Xcode over, and then now it's preparing the build. You know what? I'm gonna switch to the demo app itself. That way we don't have to wait too long for all the stuff. So terminate. And then so smart clock, that's what the project is called. And then we can close this. This is the README. Oh, actually, I forgot to talk about these. So inside this folder, you have like some content.json that can provide you like the Xcode and versions. So you can also look at this one right here that provides you more stuff. So if you want to mess with like versioning and all that, you can access those there. So now let's hide this, and then let's go back to the Gradle build. And then this is the serialization that I was talking about. And then so if I'm going to import libraries, so I'll go to build. I was in the wrong area. I was in tools. So it's build, and then you can go to edit libraries, and then you would either import it for the shared or for Compose app, which is for Android. And then if I go to library dependencies, now here it's going to ask you for the long library name. And then so let's see, just an example that I'm going to give you guys. That's it. Android library. And then I'm looking for the import. So that's what it looks like. And that's why I can never remember them. And then so when you're looking for it, it's best to just leave out the version number, because you might have you might be pulling down an outdated one. And then now if we go back here, and then you just paste this here, and then you search, and then as you can see, version 5.0.0 alpha 14 is available. And then you can just click OK, and then when you click OK, you apply and OK, and then it will import it. But we don't need it here because we're not doing any API calls. And OK, HTTP is not compatible in Kotlin multi-platform. They have something else called client. That's what you would need to use to make API calls. And that's why I also use this just to also briefly talk about it, because I know I told you guys that I love it, in the past, and that is lightweight. But when you're building for multi-platform, it's not available for now. So that means we did the same for serialization, and then that allows you to use JSON objects and create JSON objects. All right, so now we're going to go back to the code again. So we undershared, and then we're going to go to common. And here, as you guys remember, we had the platform, which is basic enough. And then we had the greeting that was just saying hello, and then giving the platform name and then whatever. So what I did, I added something to it, which is going to say code of the day. And then now I'm using a shared class. So now comes the shared logic, right? I'm using a shared class here, and then I'm getting the daily codes. And what it is, it's just a big class with a list of codes, 31 to be precise, 31 days. And then you get the daily codes, and then it's just a random, you get it randomly, and then you get the code. And then this is what each object look like. You have the code itself, and then you have an author, and then you convert it as a JSON object. So if we didn't import the serialization library, we wouldn't be able to actually, do it as a JSON object. And we wouldn't even be able to create JSON and parse it. And then as you can see here, we're importing the Kotlin serialization JSON object, and this. All right, so now let's close this. So this will be the shared logic that we will be using across the apps. And so as you can see, it's there that we have the codes and everything, and then we have a function that returns it randomly. So now we're going to go to The greeting as well. The greeting is also going to be shared, and then we pass it here. And then now we're going to go to the iOS, and then iOS. So this is where the app starts, and then we setting the content view, and this is the content view. The difference here is that I created, the one that they provided, they added the view directly in here in the body. So what I did, I created a view outside of the body, and then I'm just calling it. So, and then now I have the basic view, which is the one that came with the app, and then I have the smart clock view, which is here. So now I'm going to leave it as it is. I will run it, and then later on I will change things around, and then it will make sense why I left this. And then so this is what the basic view is. As you can remember, it's just a button that says click me, and then it will drop down and it will show the Swift and then the UI and everything. And then you will also have the smart clock, which is now the view that I've created. And as you can see, I've chosen to not use shared UI, right? So I'm writing the UI for the iOS directly here. Otherwise, I would have created a shared UI in here that they can both use. So now this is what it looks like. And then now let's go to the Android, which is the compose folder. And then main, and then let's go to Android manifest. As you can see, I'm not getting any permissions. It's just basic what it is. Then I have the main app, which is where the app starts. And then here, I can load the app view, or I can load the smart clock view. And then if I go to the reason why so notice here, this is the one that handled the smart clock view. And then, but the name itself is different, right? So the folder name is, the file name is app2, and then the UI, is called smart clock. And then the reason why I did that on purpose, so you don't confuse this app with this app, because this app is the folder name, no, the file name, and then this is the compose UI. So I could have called this like something else, and then just refer that in here. And then, so syntax highlighting has been temporarily turned off in main file Kotlin because I don't know what that is. All right, so, and then, so now let's close this. And then we're going to run it. So let's run it for compose first. Yeah, you know what? Do you guys prefer the tablet or just a regular phone?
Maybe tablet.
Okay, sure. So let's leave it with the tablet, and then I'm going to make this bigger. Let's hide this. All right. As you can see, nothing changed. Still the same UI, but down here, now I'm adding a quote. Quote of the day: happiness is not something ready-made. It comes from your own actions. And if I hide it, and then I click on it again, another quote appears. Now, if I run the iOS version, so I'm gonna run that, and then I'm gonna take this off the full screen. And then this is it right here. It's gonna, at the stuff. I already have it here. I could have just run it here, but I just wanted to show you guys that you do it here to compose it first, to compile it first, and then you can just see the code in what do you call that, in Xcode. But you can directly also run it on Xcode. So now what I'm gonna do, Xcode also offered me an emulator, which is a phone right here. And then now the app is already running. And then I'm going to replace it so that you know that that's the app, smart clock. And then if I minimize this, you're going to see. So here we have a timer. Here we have a basic UI. You click on it, you have the quote of the day. I know you can't see, but that's what it is. You click here, you have the quote of the day. So this is exactly what I meant when I said that sometimes you want to build the app and then you want different UIs, but the same, code base, right? The same backend. So when it comes to the codes, they all show the codes, they all say welcome, hello, and then they all say the version and then the code. But again, the UIs look different. Now, I'm going to make the UIs look the same because now I'm like, okay, you know what? It doesn't make sense for me to have two different apps. The same app that have different UIs. And then so now I'm going to come back here and then I'm going to run it. And then, bam, there you go. So you have the same. And then if I switch to a phone, you will see that it's going to look exactly the same. Here we go. So minor differences, as you can see, like this one has padding. This one is literally like cool looking, but same functionalities. Yeah. So that's the benefit of having, multi-platform apps, right? They don't have to look exactly the same, but anybody looking at the app understands the underlying stuff out there. So now that pretty much completes the whole presentation. I just need to go back to here and make sure I'm not missing anything. Yep. All right. So this one is now loaded. Any questions? Go ahead.
Yes. So earlier you showed some Swift code in your project.
Mm-hmm.
Is it possible to make use of that to build a UI?
Yes. So this one right here, this is actually the UI right here. So you have a text button, a text UI. You have a button, and then a VTech, that's vertical stack, VStack, not VTech. Image and text. And then you have a transition, which is for the transition part. And then
Okay,
yeah.
so currently you're using the scenario of the different UIs.
Yeah,
right?
that's what I'm using.
Okay.
Mm.
And it's also possible to define the same UI on iOS just using Kotlin.
Exactly, yeah. Using Jetpack.
Yes, to Jetpack Compose. Okay.
And then that will be for the next presentation.
Okay. Okay.
Yeah.
Okay. Makes sense.
All right, cool. So I just remembered that I did not push this code yet. So the README is not fully there. But again, let me just do something nice and dirty because I do want to just touch base that a little bit. So now let's go to README, edit, and then
Yeah. Also, maybe can you share your repo, your GitHub?
oh, exactly, yeah. Thank you. The heck? Oh, here we go. So I made it public right now, but I'm just gonna share the link in the meeting. So here we go. Just share the link. And then if we come down here, here we go. So this is the part that was missing. And then this is how we built the app. So after we, set the environment and everything, we imported the Kotlin serialization for the JSON. And then these are the snippet of codes that you guys can use, and then where you would put them. And then you have the same thing for, the app 2. You have the same thing for which one is that? For the main, where you define which UI you want to display. And then you have the Swift code right here. All right. And then what's next? So what's next? We need to integrate more features like the alarm, the weather, and then, use settings to make the app more useful, right? Like integrate AI and provide personalization, wake up, and suggestion. So what I'm thinking about is, I want to be able to just press a button and say, hey, can you wake me up at 10 and make sure that you use something that is not too harsh? Because, I don't have to go to work or whatever. Or I can just say, hey, I don't have to go to work, but I just want to wake up. I don't want to sleep more than 2 hours. And then now we will use ChatGPT, and then we'll figure out which kind of ringtone to play that will not be like too harsh, and then also add like something that will make the user feel like it's personal based on what they provided, what they said. Then the weather, I definitely need to include the weather in there. Again, I'm just throwing the features out there. We might not be able to cover all of them, but again, it's just ideas. So now, what did we learn?
Yeah.
Question.
Yes. I was gonna say that one thing you could do was also, I mean, it's just a suggestion or an idea out there.
Mhm.
Provide the services like interacting with OpenAI or the weather or any other data. Maybe you could include that API part.
Yeah. I actually was working on that earlier, but again, the reason why I stopped is because I was pulling midnight oil, right? So I didn't want to break the code and then now have to worry about that. But it's somewhere in here
No,
that
no, I mean like when you were generating the projects, you had the server part, right? That's what I mean.
Oh, okay, connect the server. That's what you say.
Yeah.
Okay. All right. So the next project, we can probably do that then. Yeah. All right. Let's do that then. Uh, okay. Let me just write a note for myself. Got it. All right. So what did we learn? We learned the basics of multi-platform development. We learned how to set up the Kotlin multi-platform project. We explored the shared code between the platforms, and then we, showed how it works. And then we gained some experience in Jetpack Compose, right? This one, I kind of lied because I didn't give you more than one example, but I gave you a link. So I'm going to assume that everybody's followed the link and then, have some understanding. So we talked about the structures of the project, the importance of the shared logic, and then the platform specific implementations. We learned how to share libraries, how to use the shared libraries and dependencies, and then gain insight and so on and so on. So the API part, we also talked about API, but not like external API. We talked about API within the Kotlin framework, and then understanding and managing the project, and then learning version control effectively. So that one, I kind of skimmed through it, which is what I was talking about here, like the versioning. And then also version control. Usually when you say version control, some people think of GitHub and all, but there's also versioning in the app as well. Let me just pull this back up. And then, so we tested, and pretty much that's it. So any questions, any concerns, anything? Was this one too long? Or was it all right?
It was actually shorter.
Was shorter? Okay, that's good. That's good. I'm doing great then. Thank you. All right. So if no questions, that completes the presentation. The link is in the chat. Feel free to download, use it, modify it. I would say just don't push to the repo. I made it public and then I didn't put any guards right now. Or if you want to push something to contribute, just create a separate branch. That way I can just review it. But yeah, pretty much it. Yep. Thank you much, everyone.
Yeah, thank
No,
you
thanks
for
to you.
teaching today.
Yeah. So I'm gonna stop the recording.
So